Very good. I think while I'm getting everybody unmuted to ask questions, I'll ask the first one. You talked about the availability and the fact that it's up to 95% and so forth. And then you also talked about your ability to support all this to maximize the availability and reliability. But ultimately, if these people have to meet so many pounds per clinker per year, any inaccuracies or in the mercury SEMS could cost them in terms of having to overshoot. In other words, you got to control and get more mercury out because you don't have 100% tracking of what's going out of the system. So you might just address that, and I'll get everybody.
No, that's Bob. That's a great point. I actually didn't touch on that. That absent seeing what's going on, then it's hard to adjust things. We got that same person that's on the case.
Yeah, we're going to have to live with the questions. We have to live with whatever. If people put their phones on mute, it'll help things.
Yeah, but
people on here. Yeah.
Yeah, Bob, that's a great point. Unless you're seeing, it seems to me, unless you're seeing the pollutant levels, or you have some kind of parametric monitoring system that you're 100% confident in, then you're not really sure how to optimize the process and pollution control equipment. And I'm not sure that people heard the answer, but Bob, that's an excellent point.
Yeah. And basically, then a further point to not only in optimizing the system, but in if you're sued for not meeting, at the end at some point in time, you're sued by either environmentalists or somebody else for exceeding the mercury limits. In order to prove that you are meeting them, you're going to have to take all the time when the monitoring wasn't available, and to factor that in. So basically, the more accurate the monitoring, the more defensible you are that you've met the annual limit.
Exactly. So, Bob, 2 points, and you're making a great one. The prior one, you have to be able to see what's going on, and then you have to be able to believe the information.
Right. That's a good way to put it. Very succinct. Yeah, let's get questions from the floor. Who's ready to ask some questions there?
Karl, this is Jim Downey. In one of your earlier slides, you mentioned that the PC MACT had removed any control on mercury in the use of clinker and fly ash. Yet EPA is also working on a regulation specifically directed at fly ash. Can you explain that a little more?
Well, actually, yeah, Jim, good question. I borrowed that slide, frankly, or one of the bullets on that from a prior Mcilvaine presentation. It was done not by me, but by someone else. But the answer I'm giving you might be tangential here. One is I don't know what EPA is going to say about the mercury levels in things like fly ash, et cetera. But if I can draw an analogy to one of the other processes that goes on in coal-fired plants, and that is with pollution control waste. If you remove some of the dimethyl terribles, if you will, from the flue gas stream, then instead of them going out in the air, they're going out in some other pathway. And the use of calcium sulfate for gypsum-producing places, now with the scrubbers having a higher content of mercury, is creating a secondary concern about the waste stream. Are we moving mercury, are we removing it from the flue gas stream with activated carbon or calcium sulfate scrubbers, FGD scrubbers, and then in the next process introducing it to some other place in the environment? And that's a big challenge. I'm not sure how that whole mass balance and environmental regulation is going to play out, but I think that's another area, Jim, where we have a lot to learn about taking it from X and moving it into Y.
Okay, thank you.
Yep.
Other questions? You alluded to the fact that you're measuring or helping customers with the measurement of the mercury in the FGD slurry. It seems, therefore, you have a lot to offer in terms of kind of advising customers on a holistic approach. And then one further aspect of that, wouldn't it be desirable to be measuring mercury on the inlet as well as the outlet in order to put all this together over a period of time? I mean, I guess you're going to have to eventually deal with both solid waste and wastewater issues.
Right. Bob, I think an inlet-outlet, there's probably two things to consider there. One is, if you had an activated carbon system, is there sufficient information and control strategies to really vary the activated carbon injection as a function of inlet mercury concentration? And I'm not sure what those averaging periods would be, but we have systems that we're working with some of the pollution control equipment suppliers that are doing inlet-outlet, and that's an interesting aspect, right?
We've never adopted it here.
The other inlet-outlet aspect is really looking at the plant as a black box, and you have mercury, for instance, coming in the raw mix and the fuel, and then what are the pathways that it's leaving the black box called the plant? Is it leaving in captured activated carbon that's captured in a fabric filter in the Portland cement process? Is it leaving in FGD slurry? Is it leaving after it gets captured in the wet scrubber? Is it getting re-emitted because of reduction reactions and chemical reactions in the scrubber? All that mass balance looking at the plant as a black box is going to be an interesting evolving science. So both of those inlet-outlet considerations, if I've articulated it well enough here for the group, are going to be high on people's list.
What kind of percentage does it add to the cost to have both inlet and outlet measurement?
Bob, if you had two dedicated systems, maybe with a shared with some shared data acquisition and monitoring, you know, frankly, from a capital equipment standpoint, if you had two dedicated systems, you'd easily be adding $100,000 to that. There are some systems that we're working on that may have just two probes in a common system, but one of the issues you have there on the inlet-outlet that people need to acknowledge is that the concentrations at the inlet, and I'm just going to make up a number, could be 100 micrograms per cubic meter, and on the outlet could be 5 or 10 micrograms per cubic meter. So the way you set up your CEM system and calibrate it and challenge it, and the levels you're looking at are going to be two distinctly different levels, an order of magnitude different. And frankly, just my own view on this is having two dedicated systems. If you believe the economics are there for savings, two dedicated systems might be more beneficial than one shared STEM system with two separate probes and umbilicals.
Yeah, and I think one message that's coming out loud and clear is that mercury monitoring, whatever you do, is going to be expensive, and it could be a lot more expensive if it doesn't do what it's supposed to do, and you end up in trouble. So
exactly,
the extra $100,000 seems like it might be worthwhile. Any final questions, and then we'll move on to Dan Keitzer. If not, thanks a lot, Karl. That was very
Bob, thank you very much for the opportunity to participate.